Hello everyone. So I'm Guilhem. I'm Kubernetes engineer and Kubernetes architect at Akamai Cloud, so US cloud providers, and I'm working mainly as for the internal Kubernetes platforms. So yeah. Quick introduction about me. Today we will talk about the grid cluster debate. So what is it? In all the technology, we have some debate and some just like strong opinions about some stuff. So maybe you know about Vim versus everything else, and you know about IDE, you know. So there is strong debate, and one maybe you don't know about is the size of a cluster. So the goal right now will be to, so we have a panel, we have three people that will talk about it, and to really know about what is the size of the clusters you should have. So maybe I could, I should have called this panel just like, is size matter? And we will know if. And so I will begin. Sherine, can you introduce yourself and also introduce the context on where you work and with how many clusters, etc., just to have some background.
Hi, everybody. So I'm Sherine. I'm in tech since a very long time ago. So I've been doing dev, but also ops at various companies. Right now I'm working at Red Hat. I'm working with the OpenShift distribution of Kubernetes. So at Red Hat, obviously, we have a lot of clusters that we manage as well. But as well as that, I've also worked with companies where we have a single cluster that grows and shrinks.
Thank you. Benjamin?
Hey, hi everybody. So Benjamin, I have been working as an infrastructure engineer for the last 10 years in France. I worked on Google Cloud Platform with GKE, on the Decathlon e-commerce. I've worked on AWS with COPS at Back Market e-commerce. And today I work on-premise with Kubernetes without virtualization on big clusters with 2,500 nodes. So yeah, different skills.
Thank you.
Hello. I hope you can hear me here. My name is Kashif. I am an open source architect at Ericsson Software Technology, and I am also a maintainer of a project called metalcube.io, and co-chair for the CNCF tag infrastructure. So I am a big advocate of running Kubernetes on top of bare metal, and then when it comes to Ericsson, although I am mostly working with the open source, but then of course I know how the product side is actually using the clusters, and we are mostly in both the spaces. We have multi-cluster or clusters with hundreds and thousands of nodes, but we are also looking into single node clusters as well.
Yeah, I will begin with you. What was the main challenging process you have to deal with? So why do you have, you say you have small clusters and big clusters. What was the challenge?
So mainly, specifically when it comes to application, right, radio access networks or RANs with, on the far edge, for those use cases, you have the necessity to have single server or single cluster nodes running. And then for the other use cases or other applications that we run in telco, for those we are using like multi-cluster mostly for our customers, where we have one cluster ranging to nodes like currently I think in hundreds, I would say not, we haven't reached thousands yet in production. But it mainly depends on what type of workload. For the applications that are more towards the edge, for those we are more looking towards the single server clusters, but then those applications which are running more in the central locations, for that we can still manage to have clusters with a big number of worker nodes, for example.
And Benjamin, you talk about big clusters right now. So why is this choice, and what was the main challenge also you faced?
The main idea is to share the workers between all the applications, because we have a lot of developer applications, so they develop their application in C#, Python, etc., and they deploy their M-chart without CRDs. And the idea is let's take the opportunity to only start with one cluster and just give them the possibility to deploy their application on the same cluster and just optimize the thing to optimize the usage of the workers, to not have like some empty workers on empty unused resources simply like that.
Okay. And Sherine, you talk about multi-clusters. What was the main challenge, and maybe what is next? What maybe Kubernetes is doing for multi-clusters?
Yes. So multi-clusters is an area where there's a lot of work that is happening. With the multi-cluster SIG from Kubernetes, who is doing a lot of work to make it easier for people to manage multi-clusters and to drive the workloads to the several clusters that exist. So yeah, it is a space where things are happening to make us be able to manage multi-cluster like cattle, the same way that we had this concept for containers. Now we are being able to have similar concepts for clusters.
And you talked before when we was discussing about, for example, cluster profile. Can you just explain it?
So, for example, one of the things that was difficult was to discover clusters. So, cluster profile is simply a way to describe your cluster. For example, you could add annotations saying this is a cluster in this region, it's in this cloud provider, for example, it provides these GPUs or not, we have these network adapters, stuff like that. With that, we can have the concept of the cluster inventory, which is the cattle, so the group of clusters, and thanks to that we are able to bring things like OCM, Open Cluster Management, which is able to be a higher level controller to manage these clusters or to send them workloads, to upgrade them, to add nodes to them, stuff like that.
Okay, and Benjamin and maybe also Kashif, so when we are speaking about big clusters, do you do multi-tenancy or is it one cluster, one team?
No, the idea is to share the same cluster between multiple teams. So the idea is they all have one namespace to deploy their application, and but I would say it works in most of our current cases. You need to be good at airbag management and things like that. But as we are using bare metal right now, we have bigger and bigger machines. So with the densification coming, we need to fill those spaces. So for sure, we try to mutualize the most possible.
Well, for us, we are also supporting multi-tenancy in a sense that we do share workers in a cluster in between applications. But when it comes to sharing one specific node or worker in between applications, we don't do that, because specifically the telco applications have the tendency to run in so they don't want to, let's say, the applications or the people who are running the applications, they don't want to share the node resources with other applications. So in that sense, we have the concepts of node pools or worker pools where we do share the workers in a cluster with other applications, but not inside a node.
Okay, so you do isolation by nodes, basically.
Yes.
Yeah. Why your applications, they don't want to share the resources? Why do you explain this?
Most of the applications have, since we are mostly running on bare metal, and then it also depends on aspects like CPU pinning and those kind of things, the application's tendency is to juice out most of the resources in a node and not share these, or not to have, let's say, noisy neighbors in that sense. And those are the main reasons that we are not sharing the nodes on the application level. But then, of course, as I said, we have worker pools, and then we share the pools inside a cluster with different applications.
And so you talk about airbag, and maybe the main advantage of having multi-clusters is You talk about airbag, you talk about do fine grain airbag. So how do you do, and how are you sure that nothing just like go wrong or go outside the namespace?
Good question. No, but in reality, the idea is like we just define some airbag first, and we also have like some tooling inside the cluster, like policies. You can use Kyverno or OPA, but we use Kyverno, and we still double check. We still have some rules inside it. But yeah, for sure, you have to. That's why I would say that when I started some time ago, it was the first step of Kubernetes. When you discover airbag, it can be hard to have a mutualized cluster. I can understand it. Perhaps it's safer to say, okay, I don't know how to prevent those kind of problems. Let's create one cluster for each of every application, so they can. So by design, it's secured. It's secured by design, in fact. But I would say that now, like Kubernetes is here for since a long time, and now people are more and more, I would say, experienced with it. So airbag management is, I would say, a commodity now. So.
And Sherine, when we are dealing with multi-clusters, we have to deal with multiple control planes. So that's maybe the drawback, the main drawback we will see with multi-clusters. How to deal with it, or is there some solutions?
Yeah, before I answer that, I want to say something about what we talked about just earlier. People are afraid when they have a single cluster. They are afraid of three things. They are afraid of their performance for one tenant being affected by something happening with the other tenant. They are also scared for compliance regulations of things like breaking out of the container at kernel level, and there was a third thing I was thinking about, but I forgot. It will come back. But for example, I was wondering the grouping the nodes and distributing workloads by groups is one way, and I don't know if any of you guys have experience with Kata containers. And they are also a way to kind of keep the workloads into their own namespaces and into their containers.
Oh, maybe I will answer. I don't have experience with Kata containers. Sorry, I'm just like panel, but I will also answer.
Yeah, we haven't used Kata containers, but we have experimented with those at least. But I do agree with your point about this, as I said, also the noisy neighbor stuff. And then, of course, when it comes to telco as well, the applications are also heavily like regulated. So the compliance, as you mentioned, is a big problem as well. But as Benjamin mentioned, yes, the things are like we have the technology at least now to also going towards that direction. And it's more and more about this access control and stuff and sharing the resources also in between multiple tenants. So I'm sure that we are going to see about that also in telco world as well pretty soon.
And yeah, and you talk about Kata containers, but the presentation just before was also about KubeVirt. So there is also some way to just like create some VMs inside one big clusters. So I want to come back to the question about multi-clusters. So how to deal with multi-clusters, and do you see it just like a pain because I have multiple control plane to manage?
Yeah, that's a good question. Basically, a few years back, multi-clusters was really restrained to the teams that have platform teams that are very big and can handle that number of clusters. But today we have a lot of things that have evolved, and multi-cluster, the SIG multi-cluster has done a lot. So we can talk about the way that we manage creating, deleting, having automation around creating and deleting clusters, as well as the way to, so we talked about OCM, but there's also Karmada and Kubefleet, I think, which is really, really new. that would help you manage multiple clusters. And we have a lot of things also like Argo CT that helps to deploy workloads on various clusters. Rancher does it as well, of course. And then observability is also a key area, because if we are SREs, we don't want to wash 100 graph panels. That's not manageable. So there's a lot of things that are happening. I don't know if you guys are also familiar with cluster sets. It's a way to create clusters that behave the same. So the concept is called namespace sameness, which means that the same namespace on all the clusters will behave the same. So we talked earlier about RBAC, for example. So the RBAC that you define for the cluster set for this namespace will be the same on all of the clusters, and this helps a lot the SREs in this way. There's also the Cluster Services API, which is a way to import and export services from one cluster to the next cluster, which makes it really seamless to talk to a service, because the same way that you have a single DNS name for the service, you will have that same concept across all clusters. So that helps a lot.
And Benjamin, because you are the one that just like doing mono clusters right now, you say that people in your team just like don't do CRDs or are using just like plain Kubernetes. What happens if someone don't?
Thank you. Thank you. So about this. So as I said, let's start with some materialized cluster. If some exceptions come, the idea is you can create new ones for those exceptions. But for example, we are currently working on this. We are currently working on having Kubernetes inside Kubernetes. So having the possibility to deploy with the open source solution Kamaji, some Kubernetes clusters inside a main root cluster. We do this for some customers that have some deployments with CRDs, and it will help them to manage this. Some specific conditions too, but I would say that the idea is not to choose one or the other, but my idea is to always start with mutualization. As I said, because of observability, because of, I would say, resource usage. But when you have some problems that comes in the road, today you take an M chart on the internet and you have CRDs everywhere, and sometimes some people, they want the same custom resource, some in different version, on different observability tooling. Perhaps you will need to create the V-cluster, I would say.
And Kashif, you work inside the telco industries, and so what is the impact of the size of cluster? Is there an impact in terms of availability, in terms of deploymentness, so the easier of deploy?
Well, of course, in terms of availability, yes, there is a requirement that as you know, there are these famous 5 nines in the telco industry, and then availability is one big thing. And also when it comes to upgrade, they heavily emphasize the applications, I mean, in telco world on zero downtime. But as I was also discussing with you offline, that we have cases for the edge clusters, for example, which we are currently investigating also, where these single server deployments tend to say that you, like Kamaji, for example, running control planes in pods and then giving or leaving out the rest of the resources for the applications. But then when it comes to upgrade of those clusters, those are really problematic. And then we are currently working, for example, in the community in Cluster API, talking about in-place upgrades and supporting those kind of use cases as well, because applications do require that, okay, you have to be available all the time, no matter what you are doing.
and what will be the right solution. I want something just like not 100% uptime, but is multi-clusters or monoclusters are something I have to just like care, just like cattle and pet. Is it something better or easier if it's pet or if it's cattle in your case, in your experience?
I don't want to side to anything. I would say that there are requirements and use cases for both the world. So multi-cluster, big fat one cluster with 1,000 nodes, as well as like single clusters. So just depends on the use case and the applications you are running.
Obviously, the question is also for you too.
Well, I picked a side. I'm sorry. I'm multi-cluster biased, let's say. So my thinking is, for example, when you have several clusters, if one is going down or one is upgrading, the others are not affected. Like even in the worst case scenario, if your centralized cluster, the one that is managing all the other cluster, goes down, basically your workload is still running. So it's not down. So you can take the time to restart or recreate your centralized cluster or management cluster, so that basically your customers just cannot redeploy or change things on their clusters at that moment. So this is the way I kind of think about it these times.
I think I have already answered to this question, but
yeah, it was more like maybe about how do you manage the blast radius? So something where how do you manage it right now?
The idea is your application. In fact, I reverse the problem in my side. It's like my question is. How do you manage all the unused resources? What's the impact of all those? What's the impact of this all this overhead on?
No, for sure. I agree with you. There are situations where we don't want to look at the overhead because we have other fish to fry. Like, for example, we have a compliance, we have certain security requirements. We have, like, for the telco, for example, you said zero downtime, things like that. So we are blind to the question, but it is a question. Resources are really not well utilized when we go multi-cluster, for sure.
Yeah, I have seen some statistics recently. I don't know if they are real, but it seems like only 20% average of resource usage in general in Kubernetes. Perhaps we should try to design, I would say, some architecture to be able to use more what we provide, in fact. So this is why I'm pushing for mutualization. But as you said, sometimes you need different needs and different solutions.
I just wanted to add one thing that during this last KubeCon, which I learned, and I really liked that idea or the way of thinking as well, that the whole cloud native ecosystem is more now still debating whether it's still CapEx or OpEx or regarding this utilization. And I do agree with Benjamin that the utilization is a big issue when you are talking about redundancy and those kind of things. But then when we are more looking towards this AI era where you have specialized hardwares and then it's not readily available in all of those clusters, and then people are talking about projects like queue and multi-queue where you are actually now queuing for the resources to be available, and making sure that the resource consumption is also hitting or going towards what it should be, because hardwares or specialized hardwares are also getting scarce. So there is that way of thinking as well.
And so yeah, AI and specialized hardware are really something. And also when you have multiple clusters, Or a team, is it not just like paying for a team to just like deploy on some like tenants? So just in terms of developer experience or SRE experience, what is the impact, and is it not just something like really hard to deal with, something like hundreds of clusters to deploy one application?
Yeah, like I was saying, there are a few solutions out there to make it seamless, because that's the key. The key is we don't want the user who is deploying his application to know that there are multi-clusters behind. We just want them to just do their kubectl apply, and then the management cluster deals with the rest. Like recently, I think it was in Atlanta that it was announced, the cluster profile changed, and now we are able to add in a secure way the RBAC. I don't know if you've seen it, right? You can add the RBAC to the, not the RBAC, sorry, the credentials, a way to do credentials that are that can be applied to all the clusters. And this way, basically, when you're doing your kubectl, you just talk to the management cluster, and then everything is handled, so to speak.
Thank you. And that's really strange, because both for the monoclusters and multi-clusters, we see that there is improvement in both cases. So you talk about Kyverno, you talk about cluster profiles. My guess is where the community goes right now. What is the expectation we could have? Is AI will just like makes big clusters just like something better to just like handles hundreds of GPUs, or do we see the community just like go on more cattle, as we see before, just like more cattle clusters?
Yeah, again, and I'm thinking which side to take on.
Hard question.
Yes, it's a hard question, but I will stay on the same note that I was actually discussing previously. Yes, as I said, AI is also pushing about the hardware scarcity to some level. But then again, I think we have more and more of these like RBAC type of things. ABAC is also being talked about. CEDAR policies are being talked about for multi-tenancy and those kind of things. So I think multi-clusters would be there. Big fat clusters would would be there with use cases. I mean the monoclusters in that sense, and of course these edge-based solutions would also be there. But then I have also seen requirements from the customers to maintain those edge-based clusters through the multi-cluster, as you mentioned, and having the concept of stretch cluster in between. So the edge cluster is at, or the target one is at some remote location, but then you have a centrally managed management cluster. So there would be at least, and we are going towards also this kind of multi-approach in all the directions.
If you go to the conferences, you have both way. In fact, you have like some open source tooling like Kamaji, doing like small clusters in clusters that more and more companies are doing something like this. You also have like a cloud provider demo showing that they can host up to like 1,000, or even recently like 250,000 nodes inside the cluster. So it's like just to show that you can have only one cluster to host everything. It's a possibility, and yeah, it depends.
It really depends. It really depends on what your company is doing, how your platform team is doing. I mean, multi-cluster is really something that is progressing really fast, but it's not necessarily all the products are at a mature level for you to do it. So I would say that you really need to think about the burden, like you said, from the resource perspective, but also from the team's perspective before going in that direction.
And yeah, and I want to talk about organization because you begin to talk about it. So the team, so who is responsible for the clusters, basically? So we are talking a lot of platform engineering right now. So the platform, who is responsible? Is the platform is responsible of all the Kubernetes, or is it responsible of just to spawn the Kubernetes? What is for you just like the best approach and the trade-off between just like homogeneity and also autonomous of any kind of team. So really about the organization and SLA perspectives, SLO perspective of your organization.
So for us, we are mainly doing it so that we manage the Kubernetes cluster and the lifecycle, and then the rest, like the application itself, is not our responsibility from our end or the product that we have inside Ericsson. So we provide the clusters and maintain the life cycles, like the upgrades and all those type of things. But when it comes to the application life cycle, we don't deal with those things.
Yeah, I mean, it's the same from the developer's perspective. We already are in a very touchy space because asking them to know about the platform side of things when they are deploying their application is very, like, it's a steep curve for them already. And if we add for them the management of a cluster, even if it's one from a multi-cluster kettle, it's a lot. So we need, in my opinion, we need to keep it this way. It's already a lot for the developer to take in.
I would say it's different if you are using a cloud provider or if you are hosting yourself. But if you are hosting a cloud provider, I would say the cloud provider manage, I would say, the first layer of the control plane of Kubernetes. Even in autopilot, you can manage a lot of things. But you still have a platform team over it to do the link with the company, integrating the deployment solution and things like this. But I would say us on Bare Metal side, we recently decided to separate the team in two teams. The idea is we have a team that is managing the project to have Kubernetes inside Kubernetes with Kamaji on how to provision a new Kubernetes cluster easily, things like this. So on operating a Kubernetes cluster, upgrading the cluster, things like this. And we have a team which is integrating those clusters for the users. So how they can deploy on it, observe their applications, things like this. So it's separated.
And so maybe a last question, it's more like, so we are talking about Kubernetes clusters, and if we go just like a little bit above, just like about platform, you talk about observability, do we have to just like give just raw Kubernetes, or do we have to choose everything about observability, about tracings, everything inside just like a platform? So who is also responsible of this part? Is the team can choose their own monitoring, but it can be just like many things, many different things.
Yeah. So yeah, observability and all the other, like you said, like policies, observability, security, all of these concerns, I believe, should still be kind of centralized in an enterprise. So platform team can set the guidelines, and then the teams can make the fine-tuning for these things. Observability is surely one of the areas where it's very very important for the teams who are operating the application at the application level to understand the metrics and the telemetry that they have available, and it's important to give them the opportunity to kind of also work their own dashboards in order to be able to see it, regardless of whether we are operating on a single cluster or multiple clusters.
Yeah, I completely agree with that. I also think that observability is something that should be coming from every layer, because when it comes to deploying workloads, telemetry is important in the Kubernetes itself if you want to really inject decisions based on how you are consuming the resources, for example. But when it comes to application as well, the application providers also need to monitor the consumption, the telemetry, and all those stuff, and the behavior of the application itself. So it is important to have the observability in all those layers, according to my opinion.
On Criteo side, we are R&D of 1,000 engineers, and we are like 300. 300 in infrastructure on the platform. And the idea is we try to centralize everything, and even the idea is we are currently migrating from Mesos to Kubernetes, and we are mainly on Kubernetes right now, but currently the idea is we don't want our users to know even if they are on Mesos and Kubernetes, so it's abstracted. So in fact, it shouldn't change anything. They should keep the same observability, centralized observability, the same, logs, metrics, things like this. They keep the alerting they have the same. So yeah.
Thank you. I don't know if you have time for questions or.
Actually, I think the timer was set wrong because it's the post time right now. But that's okay. One question: Does everyone has a question? Anyone has a question? They want the pause, I guess. Okay. Thank you very much.
Thanks a lot.
So, going forward. Just a couple things, I will repeat one of them, but right now it's the pause. Please, again, visit the sponsor booth. There's sweets and coffee as usual. And we have the last sponsor demo by Isovalent. If you know them, you know that the demo will be good, so you can stay around also. Thank you. Thank you. And the demo will be about troubleshooting network policies in Kubernetes cluster with what? Cilium. But that was good. Yeah, that was good. That was good. Yeah. Thank you.
Bravo. Je sais pas ce qu'ils ont fait avec ou